Sir, sir, your voice is not audible and
Hello, are you saying something?
Yes, sir.
Yes. What are you saying?
Sir, sir, your voice is now audible, but your screen share is not visible.
No, I haven't started yet. The session starts at 7, so I'm waiting
Okay,
till
sir. Okay, sir.
7:4,
Okay, sir.
7:5, so that some more students join, then I will start. I haven't shared my screen yet. Hello, is my screen visible? Can you let me know if my screen is visible? I forgot to start the recording, so I have to restart again. Yeah, welcome everyone to this NPTEL live session for the course Introduction to Machine Learning. My name is Avan Maiti. I'm a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. So this is an extra session. Uh, so we will discuss some questions from all the topics that have been covered in this course in 12 weeks. And if you have any questions or doubts regarding any of the topics, you can ask me during this session. So this is the first question. Suppose we want to add a regularizer to a linear regression loss function to control the magnitudes of the weights beta. So that is the job of the regularizer, that it restricts the value of the weights. We have a choice between omega of beta equals to summation over I equals 1 to p absolute value of beta, and omega 2 beta, which is equal to summation over I equals 1 to p beta squared. Which one is more likely to result in sparse weights? Option A is omega 1, option B is omega 2, option C both omega 1 and omega 2 will result in sparse weights, and option D neither of omega 1 and omega 2 can result in sparse weights. You can write your answers in the chat. Muthu Kumaran, yes, is option D. Okay. Anyone else?
So what do we mean by sparse weights?
Sparse weights means most of the weight values will become zero. Very few of them would have some non-zero value. Subarna Bhagwat says option A, which is omega 1. So the correct answer is option A, omega 1. So this the first regularizer omega 1 is actually the lasso regularizer for the lasso regression, and the second one where we are squaring the weight values, this is called regularization for ridge regression. So lasso and ridge, these are the two most popular regularizers used with linear regressions and also with logistic regressions and also neural networks. So between these two, lasso regularizer, where we're just summing the absolute values of the beta, uh, has better ability to drive the weight values to zero for most of the weight parameters. Obviously, not all of the weight parameters would become zero. Otherwise, the output would become zero if all the weights become zero. And the second regularizer omega 2 would also reduce the magnitude of beta, which is the actual goal in for regularizers, but it would not drive the values to zero. So that's why if we want sparse weights, or if we want most of the weight values to become zero, we would prefer the first regularizer omega 1, which is the lasso regularizer. And that's why lasso is also useful for feature selection or feature reduction, because for the features for those features for which the weight value becomes zero, that feature becomes useless. That feature is not being used for the computation. So in one way it is reducing the number of features. So correct answer is option A, omega 1. Now question 2. Which of the following statements are true? Option A, the chances of overfitting decreases with increasing the number of hidden nodes and increasing the number of hidden layers. Option B, a neural network with one hidden layer can represent any Boolean function given sufficient number of hidden units and appropriate activation functions. Option C, two hidden layer neural networks can represent any continuous function within a tolerance as long as the number of hidden units is sufficient and appropriate activation functions used. Multiple options may be correct in this question. So the first option says that the chances of overfitting decreases with increasing the number of hidden nodes and increasing the number of hidden layers. So if we increase the number of hidden nodes and hidden layers, complexity of the model increases. If the complexity of the model increases, it increases the chance of overfitting. It does not decrease the chance of overfitting. So in general, more complex model would have higher chance of overfitting than lesser complex models. So this option is not correct. Option B says a neural network with one hidden layer can represent any Boolean function given sufficient number of hidden units and appropriate activation functions, which is actually correct. So um, uh, that is the universal approximation theory for neural networks, that you can approximate any function or represent any function, in this case Boolean function also, if you have sufficient number of hidden units and appropriate activation functions are used. Then even a neural network with only one hidden layer can represent any function, approximate any function. So this is um, correct. Option C says two hidden layer neural networks can represent any continuous function as long as the number of hidden units is sufficient and appropriate activation function is used. So this is again true that uh, if we have two hidden layers in a network and we have sufficient number of hidden units in every hidden layer, and we apply appropriate nonlinear activation functions, we can represent any continuous function using that two layer neural network. So option C is also correct. So option B and C, these are the two correct options. Now question 3.
Sir,
Yes.
for question number two, yes. One hidden layer means in actual there will be three layers, right? One input layer, one output layer, and one hidden layer, correct?
Yes, yes, yes. Yeah, hidden layer means apart from the input and output layer, there is one
My question
more.
is
Hmm.
option B says
Hmm.
a neural network with one hidden layer. So
Hmm.
that means there will be one input layer, one
Hmm.
output layer, and one hidden layer.
Yes,
Is it correct?
yes, yes.
Okay.
Yeah.
Hmm.
So the hidden layer basically means it is apart from the input and output layer. Obviously, input and output layers have to be there. Otherwise, it would not become a neural network. Apart from these two layers, there is one hidden layer, and the third option it says two
Okay.
hidden layers. Yeah.
Your voice is breaking, sir.
Hello. I can hear you. Hello. Am I audible? Hello.
Yes, sir.
Am I audible now? Yes.
Yes, sir.
Yeah. Okay. Yeah. So one hidden layer means apart from the input and output layer, there will be one hidden layer.
Okay.
Question 3. For the given confusion matrix, so this is the confusion matrix. Compute the recall for this confusion matrix. So the rows are predicted positive, predicted negative, and the columns are true positives, true negatives. So true positive, true negatives can also be referred to as actual positives and actual negatives. So this true positives and true negatives means actual positives and actual negatives. So you have to compute the recall. So they you just have to use formula of recall, which is Tp divided by Tp plus Fn. Let me write it properly. Fn. So Tp is true positives, Fn is false negatives. So from this table of the confusion matrix, you have to find out which cell represents Tp and which cell represents Fn. So Tp means true positives, that is um, actually positive and predicted positive. So that means this cell represents Tp. Those examples are actually positives and they are predicted as positives. So this first cell represents true Tp or true positives, and Fn, which is false negatives, basically means falsely classified as negatives. That means those are not positives but predicted as positives. So those are actually positives but predicted as negatives. So this cell represents Fn or false negatives. So Tp is 6 and Fn is 3. So if we put these values into this equation, 6 divided by 6 plus 3, it should be 6 divided by 9. That is 2 by 3, which is about 0.67. So that would be option D, 0.67. So that is the value of recall for this confusion matrix. So in such questions where you have to compute precision or recall from the confusion matrix, you first have to identify which cell represents true positives, true negatives, false negatives, and then you simply have to use those cell values to compute either precision or recall, whatever would be asked in the question. So option D, 0.67 is the correct answer. Now question 4. The figure below shows a Bayesian network with 9 variables, all of which are binary. So this is the Bayesian network with 9 variables. Which of the following is or are always true for the above Bayesian network? So the first option says probability of A comma B given G is equal to probability of A given G into probability of B given G. That basically says that A and B are independent given G. And second option is probability of A comma I equals probability of A into probability of I, which basically means the variables A and I are independent of each other. Option C says probability of BH given EG is equal to probability of B given EG into probability of H given EG. So it says that B and H are independent of each other if E and G are known. And option D says that probability of C given B comma F is equal to probability of C given F, which means it says that C is independent of B if F is given. So you have to find out which of these following is or are always true for this Bayesian network. So this problem is quite lengthy. It would take some time to solve. So I will solve this question for you and also show you the steps to solve such questions. So the first option is probability of A B given G is equal to probability of A given G into probability of B given G. So A and B and this variable G is given. So we have to check the independence of A and B if G is given. So we can see that there are we have to find out whether every path between these two variables A and B are blocked or not. If every path between A and B are blocked, then A and B are independent of each other. So this is the first path ACB, this is a small path, and this is another path. So these are the two paths. We have to check that each path is blocked or not. So first we will check this small path ACB whether it is blocked or not. So in this case you have to remember the three deseparation rules. So this structure ACB comes under the third rule of deseparation, where you have this if the structure looks like this x y z and there is an edge from x to y and there is an edge from z to y, so uh, you have to be careful about the direction of the edges, and there is some descendant y dash of y. So if y or any of its descendants y dash is given, then this path between x and z are not blocked. So if y or y dash is given, then x and z, the path between x and z is not blocked, and x and if the path is not blocked, x and z cannot be independent of each other. So in this case we see that c is not given, but one of its descendants g is given. This is g is a descendant of c. So if g is given, then this path acb uh, cannot be blocked. So if this path ACB is not blocked, then A and B cannot be independent of each other. So A and B and cannot be independent of each other if G is given. So this first option is not correct. Now the second option probability of A comma I equals probability of A into probability of I. So this is the node A, this is the node I, and no other variable is given, so we just have to check whether A and I are independent of each other. So we have to check all the paths between A and I. So this is one path and this is another path. So we have to check whether both the paths are blocked or not. So first we'll check this first path. So this path would be blocked here at G. So here at G this path would be blocked. If G is not given, G would block this path here. So this path is blocked. Now we have to check the other path, which was this. So if C is not given, C would block this path here. C is not given, so C would block this path. So this path is also blocked. So both the paths between A and I are blocked. If there exists no path between A and I, then A and I are independent of each other, and this is what this option B says. So option B is correct. Then the third option says B and H. So sorry, B and H are independent of each other given E and G. So if E is given, E would block this path between B and H. So this path is blocked. Now there is one more path, which is this path. So if G is given, G cannot block this path because G comes under this third rule of deseparation. If G was not given, G would have blocked this path. G is given, so G would not block this path. So this path is not blocked. B, C, D, G, F, H. So this path is not blocked. If this path is not blocked, B and H are connected, and if B and H are connected, they cannot be independent of each other. So option C is wrong. Then we go to the fourth option, which says that C is independent of B if F is given. So we see that there is a direct edge from B to C. If there is a direct edge from B to C, B and C are certainly connected, and they are not independent of each other. There is a direct edge from B to C, so B and C cannot be independent of each other. Whether F is given or not doesn't really matter. So there exists a path between B and C, so B and C cannot be independent of each other. So option D is also wrong. So the only correct option is option B. So option B is the only correct answer, that A and I are independent of each other. Is it understandable? So you have to remember the three rules of deseparation, and you have to apply those rules on these paths. You have to check whether the two variables there exist uh, at least one path that is not blocked. If there exists at least one path that is not blocked by the deseparation rules, then those two variables cannot be independent of each other. If all the paths are blocked between two variables, then those two variables are independent of each other. So this is how you have to compute these uh, dependencies. So option B is the correct answer. Now question 5. For the given graphical model, what is the optimal variable elimination order when trying to calculate probability of capital E? Capital E is the random variable. Here this E is the random variable. So probability of capital E equals E. If we want to calculate this probability, then what should be the optimal variable elimination order? So if from this Bayesian network, this is also a Bayesian network. So we can obtain this joint distribution, probability of A comma B comma C comma D comma E. So now from this joint distribution, we have to eliminate variables in order to calculate variable for a certain variable. In this case, probability of capital E equals small e. So what is the optimal variable elimination order? In which order we should eliminate these variables to get probability of capital E equals small e? So the correct order should be A, B, C, D, which depends on the relations or the directions of these edges. So from the Bayesian network, we get this joint distribution probability of A, B, C, D, E. Now A is not dependent on any other variable, so we can easily compute the easily compute the total um, probability for the variable A using this. Then we will compute the we will eliminate the variable B, then we will eliminate the variable C, finally we will eliminate the variable D, then we will be left with only probability of capital A equals small e. So first A is eliminated by summing over all values of A, then B is eliminated by summing over all values of B, then C is eliminated by summing over all values of C, finally D would be eliminated by summing over all values of D. So we would be left with probability of capital E equals small e only. So that is the first option, A, B, C, D. Now question 6. The data points shown in this figure below have two features, x1 and x2. So x1 and x2 are the two features. Each data point belongs to one of the two classes. So as you can see, this is cross, this is some dot. So these are the two classes we have. If you have to select one feature to use in the classification problem, which feature will you choose? So two features are given, but if you want to choose only one feature, which feature should you choose? X1, X2, any one of the above, none of the above are suitable. So if we have to choose only one feature from X1 and X2, so we can see that if we choose this feature X2, X2 can easily separate these two classes, the cross class and the circle class. It can easily separate these two classes. But if we choose X1 only, at the same value of X1, we have uh, elements from the cross class and also from the circle class. So the two classes are mixed up if we only choose X1. So using X1, we cannot differentiate between these two classes. But if we choose only x2, we can see that with only the value of x2, if let's say this value is 5 for x2, so for x2 less than 5 we have one class, and for x2 greater than 5 we have another class. So only using x2 we can differentiate between these two classes, but only using x1 we cannot differentiate between these two classes. So x2 is the correct answer. X2 is suitable uh, feature to choose if we want to select only one feature. Now question 7. Suppose you are given the following data where x and y are two input variables. So x and y are the two input variables or input features, and class is the dependent variable or the target variable. And you want to predict the class of a new data point x1 equals 1, y1 equals 1 using Euclidean distance in 3nn. So this is knn with k equals to 3. In which class this new data point belongs? So the new data point is 1 comma 1. So this x1 equals 1, y comma equals 1, that is the new data point 1 comma 1. And so this is the training data set you have. So in which class should this new data point 1 comma 1 belong to? So you have to compute a lot of values here. I will simply show you the steps. So the new data point is 1 comma 1. So in KNN, the principle is that you have to find out what are the k nearest neighbors of this new data point 1 comma 1. And once you find out the k nearest neighbors of this new data point, you just have to find out the majority class among among those k nearest neighbors. So basically you have to find out the distance between 1 comma 1 and the first data point, 1 comma 1 and the second data point, 1 comma 1 and the third data point. So basically you have to find out the distance between the new data point and all the data points given in the training dataset. So for example, if you want to find out the distance between the new data point and the first data point, which is minus 1 comma 1, so the distance is measure we are using is Euclidean distance. So it would simply be this squared plus 1 minus 1 whole squared root over of that. So it would be 2 squared, which is 2. So the 2 is the distance between the new data point and the first data point in the training data. Similarly, you have to find out the distance between the new data point and the second training data point 0 comma 1, then third data point. And once you find out these distance values, then you have to find out the k nearest neighbors, k points with the least distances from the new data point. And from there we can after that, so here k equals to 3, you are using 3nn. So find out the 3 nearest neighbors of this new data point 1 comma 1, and then you have to find out the majority class among those 3 data points. So if you compute all the distance values and the k nearest neighbors, the answer should be positive class, plus class. So you can work this out later on. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 training data points are there. So you have to compute 9 distance values from the new data point to each of the training data points. It will take some time. So you can do it later on. So find out the distance values and then find out the 3 nearest neighbors, and the majority class of those 3 nearest neighbors would be the class of the new data point. Question 8. Consider the following image showing data points belonging to different classes indicated by colors of the points. I hope the colors are visible because this cluster is red colored, this cluster is green colored, and this points are blue colored. So these are the 3 clusters represented by different colors. Which among the following clustering algorithm will perform well in accurately clustering the given data points? The 3 options: k-means, complete ring hierarchical clustering, and DB scan. So Muthu Kumar and I says option C, DB scan. Okay. Anyone else? So k-means works well only when the clusters are circular shaped or round shaped, because it uses Euclidean measure, so Euclidean distance measure. So k-means can only find out circular clusters, but we can see that this cluster is not circular at all. This is a weirdly shaped cluster, so k-means would not be able to find out this cluster, even though k-mean might be able to find out these 2 clusters because these 2 clusters are circular in shape, but it would not be able to find out the third cluster. And option B, complete link hierarchical clustering, would not work well because it merges, so it is a hierarchical agglomerative clustering algorithm, so it merges 2 clusters based on their complete link distance. So if at some point these are two different clusters and this is one more cluster, it would simply merge these two clusters into one, because it uses complete link distance measure to merge two clusters. So it will merge these two clusters, uh, whereas it should have merged these two clusters. Sorry. So this it should have merged these two clusters, which it would not merge because the complete link distance is higher in the for these two. So complete link hierarchical clustering would not work. DBscan is the perfect choice for such data point distributions where the data points are the clusters are not regularly shaped. They are somewhat like concave shaped, and the clusters are density based. So DBscan is the perfect choice for such clustering problems. Question 9. Suppose the VC dimension of a hypothesis space is 4. Which of the following are true? So multiple options may be correct. Option A says at least one set of 4 points can be shattered by the hypothesis space. No sets of 4 points can be shattered by the hypothesis space. All sets of 4 points can be shattered by the hypothesis space. No set of 5 points can be shattered by the hypothesis space. Multiple options may be correct. So if the VC dimension of a hypothesis space is n in general, so that basically means at least one set of n points can be shattered by the hypothesis space, but no set of n plus 1 points can be shattered. So uh, that is in general if the VC dimension is n. So in this case, the VC dimension is 4. So at least one set of 4 points can be shattered by the hypothesis space, but no set of 5 points can be shattered by the hypothesis space. That's why the VC dimension of this hypothesis space is 4. So A and D are the two correct answers. So that is also the definition of VC dimension, that if the VC dimension is n, it can shatter at least one set of n points, and no set of n plus 1 points can be shattered by the hypothesis space. So option A and D are the two correct answers. So these were the questions that I wanted to discuss in this live session. Now if you have any other questions or queries, you can ask me.
So can you please repeat the last question?
Yeah, so VC dimension, if you go through the video lectures again, so the VC dimension of hypothesis space is defined as if the VC dimension is n for some hypothesis space, then at least one set of n points can be shattered, and no set of n plus 1 points can be shattered. That is why the VC dimension of the hypothesis space is n. So if you do not understand the VC dimension, you can go through the video lectures again. So there is a long video lecture given for VC dimension. So this is in general the definition of VC dimension, that at least one set of 4 points can be shattered, no set of 5 points can be shattered. That's why the VC dimension is 4.
What do we mean by shattered over here in case of hypothesis
So
space?
shatter basically means uh, separated or classified here. So 4 points are given. So at least one set of 4 points. So 4 points, and they would be labeled something like this, plus or minus. And it can shatter, basically means it can separate these two classes. For any labeling, it can, for any such labeling of plus and minus classes, it can shatter at least one set of 4 points.
Both,
But
if we combine both the options, then that means exactly set of 4 points only will get shattered, correct?
at least one set of
Not
four
less
points
than
can be
4
shattered.
and not more than 4.
No,
At
less
least
than
one
4.
set.
If
Okay.
if the hypothesis space can shatter at least one set of 4 points, it can certainly shatter less than 4 points.
Okay.
So that's why BC dimension is
Okay,
4.
sir.
That means less than 4 it can shatter, but more than 4 it cannot shatter. Any no set of 4 points or 5 points it can shatter.
Okay, sir. Thank you.
So if there are no other questions, we can end this live session now. Thank you everyone for joining.